Okay, welcome to part 3. So we're going to put all of our kind of knowledge together and try to find the image of our object. Okay, so what do I mean by that? Well, we did this with mirrors. So when we had a mirror, it was either plane, convex, or concave. We had to use ray diagrams to figure out where the image would be and then locate and also explain their characteristics. So we're going to do the same thing with lenses now, okay? This arrow is my object. So if you're doing this from home, please draw on 2F prime. Would you please draw a 0.5 centimeter arrow, and that represents your object. Okay, let's read our rules for ray diagrams. A ray parallel to the principal axis is refracted through F. Now we've already done that one, so let's sketch it and show what that looks like. So I'm going to take my parallel ray from the top of my object, put an arrowhead, that's my incident ray, and it's going to refract through F, right, which we've done before, and this is my refracted ray. So I'm just going to turn my paper so I can draw this. You can try to do the same thing. And don't forget to put the arrowhead on top as well. Okay, so this is ray number 1. Ray number 2, a ray passing through F is refracted parallel to the principal axis. Actually, this should say F prime. So this should say secondary. So what we're going to do is, let's watch. We've seen one similar to this before. So we're going to take an incident ray and we're going to send it through F, or F prime. Okay, so I'm going to put an arrowhead on there, and this incident ray, when it hits the lens, it's going to refract parallel to the principal axis like this. Again, I'm trying to keep this really neat so that it's accurate. Now, right off the bat, you guys, do you see that you have an intersection point of your refracted rays right here? And remember, we said for reflection on curved mirrors, wherever you have intersection, that is where your image will be. But let's do one more ray. It says ray number 3, a ray passing through the optical center goes straight through without bending. So that actually will look like this. We're going to take the ray from the top of our object, and I'm trying to line this up so again that it's accurate. It's going to go through the middle, and then it's going to, oops, hang on. Okay, so it's going to go through the middle and it's going to go in a straight path, and there's no refraction here. So here's my arrowhead for the incident ray, and then the refracted, quote unquote, the refracted ray will go through here. Here's my intersection point of all 3 lines, and what I can actually do is draw my image from the axis to the intersection. And you guys, why did I draw that upside down? And that's because the rays, they intersected underneath the axis, okay? So what I can do for this image is I can do the 4 image characteristics, or SALT. Size, attitude, location, and type. So the size, if you can't tell, we can measure the image, and the image is, it's 0.4 centimeters. It's very close to the object, so it's, we'll say it's, hang on, let me try to measure this again. Is this the exact same? Okay, it's actually 0.5. We're going to do another lesson where we look at the 5 cases. It looks like it's exactly the same thing, so we're going to say the same size. The attitude is inverted. The location, it's, I'm going to specify it's between F and 2F. Okay, so you can see where the image is located. It's between F and 2F. And it's a real image because it is actual refracted rays that are intersecting. So it is a real image, okay? By the way, when we look at our image characteristics, again, sometimes we can say magnification or size, so SALT or MALT, to figure out what the actual size is, and we'll do this calculation later, measure the image height and divide it by the object height. So HI stands for height of the image, HO stands for height of the object, and if your answer is greater than 1, then your image is bigger. If your answer is less than 1, your image is smaller. And if you get M exactly equals 1, then it's the same size. So again, attitude, it's one of these 2 words every single time. Location, you can use the key points on your scale to explain where it is, and then type as virtual or real. Okay, one more thing is let's do the ray diagrams for a diverging lens. This is also known as concave. Okay, and here's my object. We're going to try to locate the image. So I'm trying to find the intersection between refracted rays. Now for this one specifically, I'm going to use rays 1 and 3. So ray number 1, I'm talking about the rays from up here. Ray number 1 is the parallel one. Okay, by the way, this is F prime to F prime, F and to F. So for a concave lens, the prime is reversed. If that's confusing, don't worry about that right now. We're going to do the parallel ray like this. Now remember, the parallel incident ray is going to refract away as though it came from F. So it's going to refract away as though, I'm going to dot the line, the virtual side, I'm going to dot that as though it came from F. And I'm going to pick one more light ray, which is ray number 3. Now, if you read over the rules, ray 3 is the one that goes straight through the middle. And the same thing is true for a concave lens. The one that goes through the middle is going to continue in a straight line. Okay, so I'll put the arrowheads, one over incident, one on the refracted side. If I look on this side of my diagram, there is no intersection. Okay, so these light rays are diverging, they're going in different directions, there's no intersection point. But if I look at the virtual side, I do see an intersection right here, right there. Okay, I see that the dotted line that I drew crosses with this solid line. So my image is going to go from the axis to the intersection point, and that'll look like this. And I drew the image upright because they intersected above the axis. So for my salt characteristics, the image is smaller, the attitude is upright, the location is between F, and I'm going to call it O. That's the optical center. So it's between F and the optical center on the same side as object. And then the type is virtual because we have a dotted line that's helping us intersect to get the answer. All right. That's a lot to do at home, I realize that, so do your best to watch this video slowly, pause it, fill in the note, and let me know if you have any questions. There is a little ray diagram practice package that I've given you that I would like you to try. I will post the answers and do your best, okay? Talk to you soon, bye.